This is a bit of a different question. We've asked to do partial fractions, but we don't know what k is at the top. But it will work in exactly the same way. So 3kx minus 18 over x plus 4 times x minus 2. We can say this is identical to a over x plus 4 plus b over x minus 2. Multiplied through by x plus 4 and x minus 2 gives us 3kx minus 18. It's identical to a x minus 2 plus b x plus 4. I'm going to let x equal 2 to start with, which will give me 6k minus 18 is equal to 6b. So divide through by 6, b is going to be k minus 3. Put in x equals minus 4 to get rid of the b term. That's minus 12k minus 18. It's going to equal minus 6a. Divide through by minus 6 this time. So a will be 2k plus 3. Okay, and therefore f of x will equal 2k plus 3 over x plus 4 plus k minus 3 over x minus 2. In part B, we're then asked to integrate this function between minus 3 and 1. So we're going to use the partial fraction version because that is possible to integrate, whereas the other one, we need to split it into partial fractions first. So I'm just going to write that thing down again. So integral from minus 3 to 1 of 2k plus 3 over x plus 4 plus k minus 3 over x minus 2 with respect to x is equal to 21. Okay. When you integrate 1 over x plus 4, it integrates to ln modulus x plus 4. Because when you differentiate ln, you get a 1 over. There's ways to prove that, but I'm not going to go into it here. I'm kind of using just my knowledge of how you differentiate ln, and hence how you integrate 1 over x, or 1 over x plus 4 in this case. Now, if you have a constant at the top other than 1, like a 10, then it just passes through. Okay, because in fact, you could even bring it outside the integral if you wanted. And that is exactly what's going to happen with the 2k plus 3 here. So don't be put off by it. It's just 2k plus 3 multiplied by the integral of 1 over x plus 4. So we get 2k plus 3 ln x plus 4. Don't forget that modulus. It's going to come into play in a minute with the second one in particular. Then k minus 3 times ln x minus 2. Similar reasons. And this is equal to 21 when we evaluate it between between minus 3 and 1. Okay, good. Now let's sub in the 1. So we get 2k plus 3 times ln 5 plus k minus 3 ln of the modulus of minus 1. Now actually that becomes ln 1, which is actually 0. You can put it in your calculator, but I'm just going to get rid of it here. Then I'm going to be minusing 2k plus 3 times ln minus 3 plus 4, which is 1, modulus of 1. Actually, that's going to disappear as well. And I'm also going to minus k minus 3 ln modulus of minus 5, which is okay because that becomes ln 5 as well. So just to tidy this up, we've got 2k plus 3 ln 5 minus k minus 3 ln 5 equals 21. Now you could factorize out that ln 5. I didn't worry about it. I just divided through both sides by ln 5. So it just goes from here and goes to here. It just seemed a little bit more simple. Then I get 2k minus k, which gives me k, and 3 minus minus 3, which gives me 6. So k plus 6 is equal to 21 over ln 5. Remember, we're giving our answer exact. It says it a bit earlier on, find the exact value of k. So you've got to avoid putting any of this in your... Well, you can use your calculator to help you to some extent, but it will be expected to be in terms of ln. And finally, k is going to be 21 over ln 5 minus 6. Nicely done.